Okay, let's unpack this. We're diving into a concept that, well, it really tries to tackle one of the biggest mysteries out there, consciousness. How does our own subjective experience, the feeling of being, fit into the physical universe?
Exactly. And the material we're exploring today, it's a presentation outlining something incredibly ambitious, the Conscious Agent Network Unification Theory, or CANU for short.
Yeah, and they're not pulling any punches. It's described right there on the tin as a testable theory of everything.
Which is a monumental claim, right? It tells you straight away, this isn't just tinkering around the edges. It's proposing something fundamentally different.
So our goal today is to really get inside this, understand the core ideas, how it proposes bridging mind and matter.
And maybe the most exciting part, look at the actual implications and, crucially, the testable predictions they lay out. We'll basically follow the presentation structure, see how they build this picture.
Right. Think of it like we're taking a guided tour through a totally different structure of reality they're proposing. It suggests the fundamental building blocks, well, they aren't what we usually think of from physics.
And the presentation kicks off by identifying the current limitations, as they put it, where our current science hits a wall.
Yeah, they point out that physics, which is amazing at describing matter, energy, all that stuff, it just really struggles with consciousness. There's this big gap.
And it's not just a fuzzy feeling. They call out specific thorny problems, like the quantum measurement problem. The weirdness where just looking at a quantum system seems to force it to pick a state.
Yeah, why does that happen? Physics gives us probabilities, but the why of the collapse and whether consciousness is involved, that's still debated.
Exactly. And beyond quantum stuff, there's the even bigger challenge, maybe, of subjective experience itself. The presentation notes no satisfactory explanation for subjective experience, that what it's like, quality, qualia.
The redness of red, the feeling of warmth.
Right. Physics talks brain states, neurons firing, chemicals. But how do you get from that description to the actual feeling, the lived experience? There's a gap.
So the argument in the material is, because of these gaps, especially around consciousness and quantum mechanics, we need a fundamental rethink, a need for fundamental reconceptualization of reality's building blocks.
The old view, unconscious stuff governed by external laws just doesn't seem to have the ingredients to cook up consciousness naturally.
Okay, so that sets the stage. Then comes the unification section, where they introduce the core idea of CANU. And this is where it gets, well, pretty radical.
It really is. Instead of consciousness being something complex that emerges from physics, the theory flips it. It posits consciousness is ontologically fundamental.
Meaning it's not an emergent property. It's part of the basic furniture of the universe.
Exactly. It is a basic building block. It's not something that arises later from non-conscious stuff. It's there from the get-go.
So the universe isn't fundamentally empty space with tiny mindless bits floating around.
Not in this picture, no. The source says directly, reality consists of interacting conscious agents, not particles. That's the bedrock. What we think of as particles, electrons, photons, etc.
Yeah.
They're presented as patterns. Stable or recurring patterns in conscious agent networks, like ripples or structures within this vast dynamic web of conscious entities.
Okay, particles are patterns. What about space-time, the arena where everything happens?
That's another huge shift. Space-time isn't fundamental either. It emerges from agent network dynamics. Space and time, according to this theory, aren't pre-existing containers. They actually arise from how these conscious agents interact and connect.
Wow, okay. And the laws of physics. The rules of the game.
Also emergent. The idea is they arise from statistical patterns in agent interactions. You have vast numbers of these agents interacting, and their collective behavior over large scales and times creates these predictable regularities that we observe and call physical laws.
So the laws aren't imposed from outside. They're more like collective habits of the network?
That's a good way to put it. Emergent regularities. And even quantum mechanics with all its weirdness.
Yeah. How does that fit in?
The theory posits that quantum mechanics reflects conscious agent decision-making processes, the probabilities, the uncertainty. It suggested this stems from the agents themselves making choices, and importantly, having limited information about the rest of the network.
Okay, this all circles back to their core definition, which really seems to drive everything. Reality consists fundamentally of conscious agents entities capable of perception, decision, and action. That's doing a lot of heavy lifting.
It absolutely flips the script. Start with conscious agents and then try to derive matter, space, time, and laws from their interactions, rather than starting with matter and laws and trying to squeeze consciousness in later. It's a radical change.
All right, so if these conscious agents are the fundamental Lego bricks, what are they like? What are their key properties according to the presentation?
Good question. They aren't just abstract points. They have intrinsic features. First, and this is crucial, they possess subjective experience, qualia, that what it's like aspect is built right in. They feel something.
They don't just process info, they experience it, and they interact.
Oh, yeah. Each agent has perceptual capabilities. They can sense or get information from their local network neighborhood, and they have action repertoires. They can influence the network, change their state, affect others.
And how do they connect?
Through information exchange. That's the glue. That's how they interact and form this dynamic network.
Is their knowledge perfect? Do they know everything about the network?
No, and that's a key point listed. No agent has complete information about others. They operate locally with incomplete knowledge. This limitation is actually important. It introduces complexity and might be linked to that quantum uncertainty we mentioned.
Okay, so we have these interacting conscious agents with limited info. How does this abstract network actually connect to the physics we measure? This brings us to the mathematical framework section.
Right. This is where they try to build the quantitative bridge. They propose specific mappings, for instance, distance and spacetime, not fundamental. It's interpreted as the information processing cost between agents. Meaning how much effort or steps it takes for information to get from agent A to agent B through the network defines how far apart they appear in the emergent spacetime. If it's easy, they're close. If it's hard, they're far.
So the geometry of space, its shape, comes from how information flows.
Basically, yeah. And curvature, which is central to gravity in Einstein's theory, is interpreted as network connectivity gradients. Think of it like areas where agents are densely packed and information flows easily might have one kind of curvature, while sparser areas have another. The shape of space-time reflects the network's wiring.
And they offer a formula for this. We-if-agent network topology.
Yes, that's a central piece. GUN is the metric tensor. It tells you how to measure distances and angles in spacetime, defines the geometry. The formula says this geometry is a function of the agent network topology. The connections, the structure of the agent network determines the geometry. It's not just influenced by it, it is it in this view.
That's a powerful claim, mapping network structure directly to spacetime geometry. What are the immediate implications listed that follow from this mathematical setup?
Well, first it hammers home the earlier point. Space and time are not fundamental, but emergent. The math provides a basis for seeing them as derived properties.
And the geometry we actually observe.
It reflects underlying conscious network structure. The way space-time curves is a macroscopic signal of how the fundamental agents are connected and interacting down below.
But space-time looks smooth and continuous to us, right?
Yeah.
How does that arise from discrete agents?
Good point. The framework explains why space-time appears continuous at macroscopic scales. The idea is that the number of agents is just unimaginably vast, and their interactions are happening at incredibly tiny scales. When you average over huge numbers of them, the discreteness washes out, like how water looks smooth even though it's made of molecules.
And the big dream of unifying quantum mechanics and gravity.
The theory suggests it provides mechanism for quantum gravity unification. Because both the quantum stuff, rooted in agent decisions, and the large-scale space-time gravity stuff emerging from network topology supposedly come from the same underlying reality, these conscious agents. It offers a potential single framework to finally connect them.
Okay, let's zoom in on quantum mechanics then. The presentation sets up the standard quantum formalism, first wave function, superposition, entanglement.
Right. It lists the familiar players. The wave function, describing a system's state, superposition, being in multiple states at once, entanglement, those spooky connections, measurement, and collapse, the sudden jump to a definite state. Standard quantum mysteries.
And then CAN-U offers its own AG interpretation for all of these.
Exactly. It maps these quantum features onto the agent network. The wave function 3 isn't seen as an objective physical thing out there, but more like an agent's probabilistic beliefs about other agents, or the system they form. It reflects the observing agent's knowledge, or lack thereof.
So probabilities reflect uncertainty or belief. not inherent fuzziness.
That seems to be the idea. Superposition is interpreted as uncertainty in agent network states. The system's underlying agent network is in a kind of unresolved potential configuration from the perspective of interacting agents.
What about entanglement? That connection faster than light.
It's presented as correlated agent decision-making across the network. The non-local quantum correlations are seen as agents, even distant ones, making linked choices or influencing each other non-locally through the network structure itself.
In measurement, when we actually look.
Measurement is just information exchange between agent networks. It's not a special process. Any interaction between the system network and the observer network, which could be just another agent, counts.
Leading to the collapse.
Which is the resolution of uncertainty through interaction. When information is exchanged, it forces the interacting networks to settle on a definite state. They stress no arbitrary collapse. It's a natural consequence of agent interaction. The interaction is the resolution. And they even try to map this onto Einstein's field equations, Guillotin, relating curvature to energy momentum.
How does that fit the agent picture?
Guillotin, the curvature side, is again network connectivity patterns. Makes sense with the geometry idea, but tin, the energy momentum side, is interpreted as agent information density. So mass and energy, which curve spacetime, are seen as reflections of how much information processing or how many agents are concentrated in a region.
So gravity itself.
Gravity emerges from information processing constraints in the network.
Yeah.
How information flows, how dense it is, defines the gravitational field.
Okay, this leads back to the problem, the measurement problem. System in superposition interacts, collapses. But why?
Exactly. And the canny solution claims to provide the why. Measurement interaction between observer and observed agent networks. Just agents talking to each other, exchanging info.
And that exchange forces the issue.
Yes. Collapse. Information integration forcing definite outcomes. The very act of integrating the information from the interaction resolves the uncertainty. It's not a separate step, it's part of the interaction dynamics.
What about the quantum probabilities, the Born rule?
The Born rule explained through agent decision-making statistics. The probabilities we see emerge from the collective choices and statistical behavior of all the agents involved in the interaction.
And the observer, does it need to be a human looking?
This is key. Observer paradox resolved. Because the fundamental entities are conscious agents, observation isn't special to humans or complex systems. All agents are observers in the sense that they perceive and interact. So the paradox dissolves. Any interaction can resolve uncertainty.
So the observer effect isn't about human minds specifically, but a basic feature of how these fundamental conscious agents interact.
That's the proposed interpretation. It's baked into the fundamental dynamics, not an add-on for complex systems.
Okay, let's scale up. The presentation talks about network levels. How does complexity arise from these fundamental agents?
It proposes a hierarchy. At the bottom, you have the fundamental agents operating at the quantum scale. They combine to form composite agents, think atoms, molecules, stable patterns of fundamental agents.
You got.
Then arrangements of those form complex agents, which they link to biological systems. And even higher meta-agents corresponding to conscious organisms like us with highly integrated experience.
And beyond individual organisms.
They even propose collective agents, social systems, maybe ecosystems. The idea is that this agent structure repeats at different scales.
Are these levels separate or connected, the cross-level properties bit?
Definitely connected. Higher levels show emergent properties from lower levels. Complexity rises bottom up. But crucially, they also propose downward causation to lower levels. The state or activity of a higher level system, like a brain, can influence its constituent parts, neurons, or the agents making them up.
And information flow is key across levels.
Absolutely. Information integration across scales. It's not just happening at one level. There's a formula mentioned, level n plus 1 equals phi level n, network topology, suggesting the consciousness at one level depends on the integration below it and the network structure at its own level.
This clearly connects to integrated information theory. What's the quick version of IIT from the source?
IIT, developed by ToE, proposes that consciousness corresponds to integrated information. It uses a measure, phi, calculated as h whole or h parts, basically asking how much more information the system generates as a whole compared to its parts separately. It measures irreducibility.
And can you extends this, the can you extension?
Yes, it takes IIT, but applies it to the agent network. So quantifies agent network integration. IIT's consciousness measure becomes a measure of how tightly knit the conscious agent network is.
So higher IPs?
Higher, more unified conscious experience. The more integrated the network, like in a brain, the richer and more unified the subjective experience.
Does the way the network is wired matter?
Yes, according to this, network topology determines consciousness quality. The specific structure influences the kind of experience, not just the amount. This adds a structural dimension to IIT.
And this helps with problems like the binding problem in neuroscience? How separate brain activities feel like one experience.
It claims to. It explains binding problem by saying that unity comes directly from the information integration across the whole brain's agent network.
And potentially gives us a way to measure consciousness.
That's the hope. It provides metric for consciousness measurement via IA, quantify the network integration, quantify the consciousness level.
Okay, so we've seen interpretations for particles, space-time, laws, quantum mechanics, consciousness levels. How does the physics we actually use, like the standard model, emerge from this underlying agent reality, the derivation process?
Right. This is the proposed path from the fundamental network to everyday physics. Step 1. Start with discrete agent network. Local interactions between individual conscious agents.
Step 2, get to the big picture.
Take continuum limit, large and small interactions. Consider zillions of agents with tiny interactions. Average over large scales, the discreteness fades, looks continuous.
And how do fields, like electromagnetic fields, arise?
Agent states field configurations. The collective state of many agents in a region manifests as the value of a physical field there.
And the way fields change and interact.
Agent interactions field dynamics. The rules governing how agents interact, when viewed in this continuum limit, become the equations describing how fields evolve.
And geometry again?
Network topology, space-time geometry. The network structure dictates the emergent space-time shape.
Leading to the final claim.
The result. Standard model emerges as effective theory of agent network dynamics at low energy scales. This is key. The standard model, our best theory of particles and forces, isn't fundamental in this view. It's an effective theory, a really good approximation that works well at the energy scales we usually probe, describing the collective patterns of the agent network, but not the agents themselves.
Let's shift from the very small to the very large. The subcosmological timeline. How does Kine view the universe's history?
It reinterprets cosmology through the agent network lens, the Big Bang. That's the initial agent network formation, the beginning of the network itself.
Inflation.
Yeah.
Super rapid expansion early on.
Inflation, rapid network expansion phase. The agent network itself grew incredibly fast.
And galaxies, stars, structure forming.
Structure formation, agent clustering, and hierarchy development. Agents clump together, forming those composite, complex, and higher levels on a cosmic scale.
What about dark energy pushing things apart now?
Interpreted as dark energy acts as network expansion pressure. Some inherent dynamic within the agent network causing it to keep expanding, may be related to the agent's action capability.
And the possible end, heat death.
Heat death, maximum entropy agent configuration. The network settles into a state of maximum disorder, minimal structure, minimal integrated information. And following this reinterpretation, they list some broader cosmological predictions.
Okay, like what?
One is that the universe has inherent directionality, increasing complexity. It's not just random. The network dynamics tend towards more complexity over time.
Anything about consciousness on a cosmic scale?
Yes, a pretty striking one. Consciousness density increases over cosmic time. The idea is that the overall amount or intensity of consciousness, maybe total in the universe, is growing as it evolves. It's not just a planetary fluke, it's a cosmic trend.
Wow. So consciousness is becoming more prevalent across the universe.
That's the prediction. Symbolically, increasing function of time, total integrated information grows. They also suggest the fine-tuning explained by conscious agent optimization. Why are the physical constants just right for life? Maybe the agents optimize them early on.
And eternal inflation, the multiverse idea.
Seen as eternal inflation as network branching process. The network keeps expanding, creating new branches or regions, pocket universes.
Okay, now for the really critical part, making this a testable theory. The specific experimental predictions. This is where it gets really interesting.
Exactly. Can we actually design experiments to see if reality is made of conscious agents? They say yes, and here's how.
Hypothesis 1. Quantum measurement outcomes should correlate with observer consciousness levels. That sounds provocative.
It is. It suggests the observer's subjective state, quantified perhaps by a Gatti, directly affects quantum results. The experimental design involves using IT or something similar to measure observer consciousness. Then you perform quantum measurements with varying A observers, do standard quantum tests, but see if the results change depending on the measured consciousness level of the person involved.
And what do they predict will happen?
Higher A observers show different collapse statistics. The probabilities for quantum outcomes should actually be measurably different depending on the observer's level of integrated consciousness.
Can you give specifics? The expected results.
Key 1. A-dependent Born rule modifications. The standard rule says probability depends on the wave function squared. They predict P outcome. The probability depends on both the quantum state and the observer's I. Also, consciousness-correlated decoherence rates. How quickly a quantum system loses its quantumness might depend on the observer's I. Higher I affects quantum coherence, maybe speeding it up or slowing it down.
Even things like the double slit experiment.
Yep. Observer-dependent quantum interference patterns. The pattern itself might change based on the observer's measured consciousness level.
Wow, okay, that's a direct link between mind and quantum matter. What's hypothesis 2?
This one involved gravity. Gravitational fields should exhibit subtle correlations with nearby consciousness, linking consciousness to space-time curvature itself.
How on earth would you test that? Can thinking bend space?
The experimental approach suggests using ultrasensitive detectors we have, like gravitational wave detectors, LIGO Virgo. Look for tiny local gravitational fluctuations near experiments involving high levels of coordinated consciousness, like mass meditation, or measure local gravitational field fluctuations near high systems, maybe areas with lots of conscious activity looking for anomalies correlated with that activity. The goal, look for consciousness-correlated space-time distortions.
What are the A-predicted effects? Big ones.
No, weak but measurable gravitational anomalies. Tiny effects. But they predict a correlation between consciousness states and local space-time curvature. Higher late might cause a minuscule but potentially detectable local warping. And these effects might be enhanced during high coherence mental states, like focused meditation. The formula Dig's a local X coupling constant suggests the change in geometry is proportional to the local X times some tiny interaction strength.
So consciousness could have a tiny gravitational footprint. Amazing. Hypothesis 3.
This one's about non-locality. Conscious agents should exhibit non-local correlations beyond classical limits, potentially mirroring quantum entanglement.
And the experimental protocol for that sounds ambitious.
Very. It involves a global network of consciousness measurement devices, synchronized worldwide. You'd monitor for correlations during significant events, big global moments, perhaps to see if consciousness measures spike or correlate across distances faster than light could travel. They explicitly want to test for faster than light information transfer between conscious systems. Can conscious states be linked instantaneously across the globe?
What expected findings would support this?
Consciousness correlations exceeding light speed limitations. Finding statistical links between consciousness measures that defy classical explanations. Maybe global consciousness coherence during major events. And significantly, violation of classical locality bounds for conscious systems, referencing Bell inequality bounds. Just like entangled particles violate Bell's limits, maybe conscious systems do too, hinting at fundamental non-locality. They even mention temporal correlations, connections across time. The formula C, Bell inequality bounds, makes the prediction explicit.
So potentially, consciousness itself could be entangled across space, maybe even time.
That's the mind-bending implication they're suggesting we test. The presentation also applies this agent network thinking to more familiar systems, specifically the brain and AI.
Right, the neural network, agent network section. How does it see the brain?
It proposes neurons as complex conscious agents. Maybe individual neurons aren't just simple switches, but have some rudimentary agent properties.
Then synapses.
Synaptic connections, agent interactions, that's the information exchange. And things like neural oscillations, brainwaves, are seen as network synchronization, reflecting coordinated agent activity. The upshot, consciousness integrated brain-wide agent network. Our experience arises from the whole integrated network activity.
What predictions follow from this brain view?
Well, consciousness correlates with network integration measures, like aconsciousness, Referral integration, network topology. Measuring brain network integration should correlate with conscious state, It suggests anesthesia disrupts agent network coherence, explaining unconsciousness as a loss of integration. Brain damage affects agent network topology, linking physical changes to network structure changes and thus cognitive conscious changes. And it offers an explanation for neural binding through this network integration.
And what about artificial intelligence? Can machines be conscious in this framework?
The AI consciousness criteria section lays out possibilities. For an AI to be potentially conscious, it would need information integration and threshold, high irreducible information processing.
What else?
Network self-organization capabilities, ability to rewire itself, adaptive decision-making processes, genuine choice, not just executing code, and maybe even subjective experience indicators looking for qualitative signs, not just task success.
And the implications for AI?
A big one. Tree AI requires agent network architecture. Maybe conscious AI needs to be built differently, mimicking these agent dynamics. It reinforces consciousness is not substrate dependent. Silicon could potentially host it just like carbon if structured correctly. So machine consciousness is theoretically possible if its A reaches some threshold. Machine consciousness, AI AOR threshold, which of course raises huge ethical considerations for conscious AI systems. If we can create them, what are our responsibilities?
Okay, doing these experiments, developing the theory. It needs tools, faces problems. Let's talk practicalities, available technologies. What do we have now?
The source lists things like advanced EG fMRI to measure brain states, maybe proxy for OM. Quantum interference experiments are needed for the consciousness quantum tests. Gravitational wave detectors, LIGO Virgo, for the gravity tests using their extreme sensitivity.
And for the non-locality stuff?
The global sensor networks would be needed for synchronized measurements. And critically, machine learning for pattern detection, because you're looking for tiny signals in noisy, complex data from all these experiments.
But we need more than what we have now. The required developments.
Definitely. Top of the list. Improved consciousness quantification methods.
Yeah.
We need better, more reliable ways to measure A or something like it. Also, higher precision gravitational measurements, possibly needing new kinds of local detectors for the subtle predicted effects.
What about the quantum experiments?
Need better quantum state control and measurement to cleanly isolate the potential consciousness effects. And for the global tests, enhanced global coordination protocols for precise synchronization across sites.
Is there a sense of timing for starting these tests?
The source is optimistic, suggesting initial tests possible within 2 to 5 years, thinking proof of concept experiments are within reach soon with focused effort.
But it won't be easy. The challenges section is pretty upfront about the difficulties.
Oh yeah. Technical challenges include the cell consciousness quantification difficulties. It gets really hard. Simulating these complex network dynamics is another massive hurdle, likely leading to cell computational intractability for large networks. And the measurement precision requirements are extreme.
And the theoretical side has challenges too. Theoretical challenges.
Yes. The incomplete mathematical formalism needs much more work. The exact unclear emergence mechanisms, how space-time, etc., precisely arise needs detailing. There are scale bridging problems, connecting the micro-agent level to the macro world consistently, and ensuring consistency with established physics, where it's known to work, is crucial.
How do they suggest overcoming these, the cell mitigation strategies?
They propose things like develop approximation methods for the computations. Crucially, focus on testable predictions to get empirical feedback even if the theory isn't fully fleshed out. Collaborate across disciplines is essential. Physics, neuroscience, philosophy need to work together. Iterative theory refinement. Learn from experiments, adjust the theory, and build research community and training to get more people working on it. And practically, secure funding for long-term development. This is a marathon, not a sprint.
There's also a longer timeline proposed.
Yeah, broken down. Short term, 1 to 3 years, is about setting up. Develop measurement protocols, design initial experiments, refine the math, build collaborations.
Medium term.
Medium term, 3 to 7 years, is about doing. Conduct proof of concept experiments, build computational models, test specific predictions, integrate neuroscience findings.
And the long view.
Long term, 7+ years, aims for validation and impact. Large-scale experiments, exploring technology applications, integrating the paradigm if successful, and assessing the societal implications.
Beyond the hard science, what are the broader implications mentioned? Scientific impact, the societal impact, technological applications.
The S scientific impact could be huge, a potential unified theory of physics and consciousness, driving new experimental methods, fostering interdisciplinary frameworks, and opening up technology development opportunities.
And for society.
Potentially profound societal impact. An enhanced understanding of human consciousness, maybe new ethical frameworks for AI, potentially new approaches to mental health, and a major philosophical worldview evolution towards this conscious realism.
Any specific tech foreseen?
The technological applications are speculative but intriguing. Consciousness-based computing, maybe? Enhanced brain-computer interfaces? Quantum consciousness sensors, integrated information systems designed using these principles.
How does KNEU see itself compared to other big theories? The comparison section. Classical problems, Ikeni solutions, theory strengths, weaknesses.
It claims unique answers to classical problems. Hard problem, consciousness fundamental, mind-body, no separation, unified agent reality. Free will, agent choice within network constraints, personal identity, continuous agent network evolution. Other minds, maybe direct agent-to-agent interaction. It's framed as that paradigm shift from materialist to conscious realist worldview.
And versus string theory or loop quantum gravity.
The comparison highlights aid and use focus, string theory, elegant math, potential unification, but listed as having no consciousness integration untestable. Loop quantum gravity, background independent, discrete space-time, but no consciousness component, limited scope. IIT quantifies consciousness, empirical grounding, but limited to neuroscience, no physics integration. Many worlds solves measurement problem deterministically, but infinite universes, no consciousness role.
So KNEU's niche is?
Its listed strengths. It unifies physics and consciousness, has testable predictions, and addresses hard problem. Its weaknesses requires that paradigm shift involves complex mathematics still developing and is early stage. The comparison emphasizes its unique attempt to bridge physics and consciousness directly with testable ideas. And just briefly, they flash some K-core mathematical elements to show the formal structure they're aiming for.
Like what kind of math?
Things like agent-state evolution equations, UHNet, network Hamiltonian, HNet, defining the space-time metric from network connectivity, a formal consciousness measure as an integral over partitions, and tying information integration back to IIT's whole H parts. It shows the intent to build a rigorous mathematical basis.
Okay, wrapping up the core ideas from the presentation, what are the main key takeaways they want people to remember?
It boils down to a few points. 1. E-consciousness as fundamental offers unified explanation. That's the core proposition. 2. Testable predictions distinguish Judean U from alternatives. Emphasis on empiricism. 3. Current technology enables initial experimental validation. It's not pure sci-fi. We can start testing now. And 4. Paradigm shift required but scientifically justified. It's radical, but they argue the current problems justify it.
So what do they propose as the immediate next steps to get this ball rolling?
Concrete actions. Form interdisciplinary research consortium. Get the right people together. Develop experimental protocols. Design the actual experiments. Secure funding for initial tests. Needs resources. And, begin consciousness measurement standardization. Agree on how to measure consciousness reliably.
Reflecting on all this, from fundamental agents creating space-time to testing if meditation affects gravity, what really stands out to you about CNU?
For me, it's the sheer audacity of tackling the consciousness-physics gap head-on by making consciousness fundamental. It just completely inverts the usual way of thinking.
Yeah.
And crucially, that it doesn't just stay philosophical, it proposes specific, tangible, albeit incredibly difficult experiments. It offers a potential path, however steep, to actually investigate these deep connections scientifically.
Yeah, it really makes you reconsider basic assumptions. If consciousness is the bedrock, and space-time is just how agents connect? What does that imply about our reality? If experiments hinted that our subjective states really do correlate with quantum events or space-time geometry, how fundamentally would that shift our understanding of who we are and our connection to the cosmos? Linking our inner experience directly to the universe's deepest structure, that's something to think about. Well, thank you for joining us on this deep dive into the conscious agent network unification theory.
It's definitely a complex, maybe even bewildering, but potentially game-changing set of ideas. And it lays out a specific experimental path forward, which is exciting.
We hope exploring this material gave you a clearer sense of CNU's core concepts, how it tries to solve some huge problems, and the challenging but fascinating road ahead for research. If you found this deep dive interesting, maybe share it with others who ponder these big questions about reality and consciousness. We'd love to hear your thoughts and comments too. What parts of CNU struck you as most compelling, or maybe most questionable? Let us know. Thanks again for spending this time with us, exploring the very frontiers of unified theories.